Alright, so I'm doing this problem, which is a force problem, and it involves 3 different charges. The 2 charges right here are going to be affecting this one. We're trying to find the forces acting on this individual charge. This charge is a 1 nanocoulomb positive charge, and the 2 charges that are affecting it are these two. They are a 2 nanocoulomb charge 1 centimeter away, and then a negative 2 nanocoulomb charge another centimeter away. So first off, I'd like to start out with a free body diagram. So here is A, and the charge, since it's 60 degrees and these two are positive, is going to be pushing away, right, like so. And then since this is a negative and positive, this is going to be attracted to that, so it's also going down that way. And as you can see, both of these angles are 60 degrees, so you can draw out a little triangle right here. And these angles are also going to be 60 degrees as well. And if you can't already see it, the geometry is pointing towards the fact that the x components are going to add up to a number, and that the y components are going to cancel out. So now I'm going to use Coulomb's law and find the magnitude of the forces. So we have force of B on A, which is B on A right here. And using Coulomb's law, it's a k QQ over r squared. So we have k, which is 9 times 10 to the 9th. And then Q1 is going to be the 1 nanocoulomb, so 1 times 10 to the negative 9th. And then the other charge is going to be 2 times 10 to the negative 9th. And the distance is 1 centimeter, but it needs to be in meters, so it's going to be 0.01 meters squared. And that turns out to be 1.8 times 10 to the negative 4th coulombs. And now that we have that, we're going to do the force from C to A. So we have force from C to A. Using Coulomb's law again, we have 9 times 10 to the 9th times the first charge again, 1 times 10 to the negative 9th. And then again with the negative 2 coulomb charge, which we're going to just assume is positive. But when we write the answer, it's going to, well, once it's in component form, it'll become negative in one area. So let's see, 2 times 10 to the negative 9th. And distance is the same as the same one from B to A, so 0.01 squared, which is also equal to this one. So now I would like to break these into components. So we have force on B to A in the x direction, and the force from B to A in the y direction. And this is 1.8, using this, 1.8 times 10 to the 4th, or 10 to the negative 4th. And then since it's in the x direction, it's going to be the cosine. So cosine, and then the degree is 60 degrees. And same thing for this one, except it's going to be sine for the y component. So we have 1.8 times 10 to the negative 4th sine of 60. And these come out to be 0.9 times 10 to the negative 4th coulombs. And this one comes out to be 1.5 times 10 to the negative 4th coulombs. And quick pointing out, as I said before, the y components will cancel, and you can see that the force from B to A in the y direction is positive in this case because it's going positive x and then positive y. In this next case, it's going to be going positive x and negative y. So we'll add that on as we go along. So we have force of C to A in the x direction, then force of C to A in the y direction. And it comes out to the same thing. It's 1.8 times 10 to the negative 4th cosine 60. And that becomes 0.9 times 10 to the negative 4th coulombs again. And then now we come to the y where it's negative. We're just going to put 1.8 times 10 to the negative 4th sine 60. And that's going to be a negative 1.5 times 10 to the negative 4th coulombs. So as you see, these two cancel out, and then we're going to go ahead and do a summation of the forces in the y, and then the summation of the forces in the x. And forces of the y, you add the 2 up, and that equals 0. So there's going to be no upward component. And then forces in the x turn out to be 1.8 times 10 to the negative 4th coulombs. And as you can see from this, they're both going in the right direction, so it's going to be to the right. And that is the final answer. That is the magnitude and direction of the component.